Good morning, everybody. So this week is Class 8, and I want to take a little bit of a step back to some degree. I've gotten a couple of emails that some students are getting a little bit buried and with the information, and in particular, once we really get in here and start working on these projects, a lot of questions and concerns come up. So I want to slow us down a bit. For those of you that are just plowing ahead, that's okay. That's great. And my suggestion would be, now that we know the fundamentals, there's plenty of tutorials for you to push into your own direction. So that's strongly encouraged for sure. But I want to make sure that we don't have half the class being left behind. So I want to slow down just a bit. And so today what we'll do when we get together in teams at 1 o'clock is we'll review our second pass of the rigid body destruction. That'll also give us some time to talk about technicalities of working with our rigid body simulations in Houdini. So we'll use it as a review, or I should say like a critique of our second pass, as well as a time for us to review our technical tools and methodologies we have. And then hopefully that'll get everybody back on track. So here in my I'm sorry, that's not my recorded lecture, which is technical anyway. But in my recorded lecture here, I wanted to point one thing out. So as sophisticated as Houdini is, I can tell you it's always a big question of how to do a simulation like this. See how it looks like it's exploding. All those pieces are exploding from a finite location inside there. And we can't really achieve that with anything that we've learned so far. Like we can't put none of our pop forces will take care of this for the most part. And we didn't really talk about a lot of the other forces, but I wanted to do a walkthrough on how we can create this type of explosion trigger here, where everything looks like it's coming from a finite point, because we do that a lot in CGI, and you can do some searching out on the internet and you'll find all kinds of ways to do this in Houdini. Some are insanely complex. I think I've found the simplest solution to this, and this is just using a force node. So I'm going to go into first of all, let me do it this way. So I have another geometry node here. So it's this object. That is actually the force right there. So if I go into this geometry network, this is a metaball. So in order to create a finite location for a force node, you have to use a metaball for whatever reason. I'm not sure. So in here, what I did is I made a metaball. I could just right click and type in META for metaball, and right there it is, a metaball. And then I attached a transform node to place it where I want the force to occur. So that's what the transform node's doing. It's just placing it right there, right where I have the large Voronoi cracks. So that's what I have here. So now if I go into my DOP network, the force that I'm using is actually a magnet force. So you can see I put the magnet force right above gravity, and you can find the magnet force from the forces category here. Right there it is, magnet. Or you could just tab and type MA for magnet, and there it is. So it's right above the gravity node. And in the magnet force, now magnet force, as the name suggests, sucks things towards it. Well, what I did is I just changed the scale force to a negative value, so it repels instead of attracts. And then the other thing that I did is most of these force nodes will have this second input here called data to attach. And this is where we bring in that metaball to tell it that this is where the force is originating from. So the way we bring that metaball in from up here Remember, it's in the geo node here. The way we get it into the DOP network is with what's called a SOP geo node. SOP geo. I was just thinking if we have, do we even have an object? Yeah, we don't have an object merge in here anyway. Yes. So this is the way we get it in. So again, I can get this one by tabbing and just typing in SOP for SOP. And I just select the first one there. So again, it's SOP and it's SOP geometry right there. That's this node. So this node, in this node, all I have to do is browse for the object. And you notice I didn't do my proper layout here. So I went into that geo node and grabbed the last node, which is a transform. I probably should have a null there instead. Why don't I go do that? Just to make this, to keep this consistent with what we've been learning. So I'm going to tab and type in null and put my null node down. And I'll just do out, I'll just say out force. All right, so there's my out force. So then if I go back to the DOP network, to my SOP, my SOP geo node, under the SOP path here, I'll hit the browse button. And I'm going to browse to the out force node. There it is. And then that's just wired into the data to attach. And that's it. Then that will give us that explosion. You see it wherever that, now the metaball is larger here than it actually is up in the geo node, and that's, it will change depending on how you scale the force. So if I make the force like -1, I'll usually, let me see, it gets smaller. So depending on how much you scale the force that SOP geo node is attached to, it will just make the metaball bigger in here, just sort of as an indicator of how much force is there. So again, I think I had it at -2000. And I think I can, well, it should hide it in there, although it's not. So if I run it, there we go. So if I move this somewhere else, it would explode from that location instead. So that's one tricky thing. There's I don't even know if in the documentation it says for the magnet force that the data to attach or one of it that it tells you exactly what data it is. I found that haphazardly that it's a metaball. I have to put a metaball in there. So that's the trick. So as long as you know how to do that, you know that the data to attach on these different forces is a metaball, you can now manipulate them a lot easier. So I wanted to point that out because, as I said, this is the type of motion that we're looking for a lot in our simulations. So I wanted to give you some tools to create that type of explosion or explosive force. All right, so that's the only thing I wanted to cover in here. This is a really quick video. But again, I think that's fine. I want to make sure we're all on the right track. I want to make sure we all have our second pass at the rigid sim done so that we can move forward next week. Next week, we will do integrating into game engines. And I have two methodologies for getting our rigid simulations into the game engines. One method is just simply called RBD to FBX. And then a more complex, but what do I want to say? It's more complex, but a tighter integrated method is by using what's called a vertex animation texture, which is, we have to get into some shader work. But what it does is instead of it basically is going to hold your entire animation, all of those points that we see here. It's going to hold all of those points, or I should say it will contain the animation data of those points in a single texture map. So it uses a texture map to determine how things move, which is really pretty sophisticated. So we'll take a look at both of those methods next week. And then after that, we'll move on to particles and pyro. So that's why let's slow down a bit here, make sure everybody is comfortable with their rigid simulations before we move on to something else. So So this is all I'm going to cover in the lecture video here, and I will see everybody this afternoon at 1 o'clock in Teams.